Hey everyone, today I'm going to be walking through the improvements I made to a pharmaceutical document RAG pipeline, which is a chatbot that answers questions about pharmaceutical documentations. I'll focus on what I changed, the problems I ran into, and how I First, I'll give some quick context on what this actually does. The input is what's called a blob PDF, which is a single file that bundles together several different pharmaceutical document types. Here's the user interface before uploading. And here it is with the PDF. After uploading, the pipeline detects where one document ends and another begins, classifies each page's types, chunks the text, builds searchable indices, and then lets user ask natural language questions, routing each question to the right document type and returning an answer with a page level citation. That citation piece matters a lot here because pharmaceutical documentations has to be traceable. You can't just give someone an answer. You have to show them where it change I made was the embedding model. I switched from mini LM to BGE small. It's slightly slower, but it gave noticeably better retrieval, so more precise chunks with better coverage of fine-grained details. For a use case where someone's asking about a specific lot number or an expiration date, for example, that small speed trade-off was worth it. This was part of a previous chunking. Originally, I used a single fixed size splitter, but I ran into a real big problem early on. When I asked a simple question like, what are the specifications, the bot returned an entire page of text instead of a short answer. It turned out my paragraph splitting logic relied on blank lines that weren't actually present in the extracted PDF text, so the whole page became one chunk. I fixed this by moving to a two-stage hybrid approach. First, semantic splitting, which breaks text at natural topic shifts, followed by a sentence level cap, so nothing exceeds a set size. That fixed the root cause instead of just patching around it, and it also let me preserve page range metadata for retrieval. I moved from a single vector search to a hybrid approach, running both vector search and BM25 keyword search, then merging the results. This mattered because vector search is great at semantic matches, but it can miss exact identifiers like lot numbers or certificate IDs, which BM25 catches directly. I also added a re-ranking step using a cross-encoder, which resources that merge results for better precision. That introduced its own bug though. The re-ranker returned raw, unbounded scores, not a clean 0 to 1 range. Without fixing that, my UI was going to display nonsense numbers like 245% confidence. I fixed it with a sigmoid normalization so the score stays in the range the rest of the One of the bigger unplanned problems I faced is that I built this against Gemini, but the limits were horrible. So I had to migrate every model call to OpenRouter's OpenAI compatible format and adjust how I parse responses. One problem I still face is that I hit OpenRouter's free tier rate limit partway through testing, since a single 10-page PDF can trigger 15 to 20 API calls just from classification, bounding detection, and routing. This is a problem I have yet to change how routing works. Originally, routing picked exactly which index to search, and that decision directly determined the results. Now, routing only narrows down a candidate pool, and the hybrid search and re-ranking do the actual ranking afterward. That's more accurate, but it does mean that I'm rebuilding a small index per query now, instead of reusing one, something I need to revisit if they scale to thousands of documents. I also found a subtle UI bug. The shortcut buttons like summarize this document were silently ignoring whatever filter or settings the user had actually selected and just use default values instead. No crash, just wrong behavior. The cause was the button's functions was reading a frozen snapshot of the component's value instead of its live value. I fixed it by passing those components properly through Gradio's. So overall, every change here targeted a specific weakness. A lot of the debugging wasn't about crashes at all. It was silent issues like the stale UI values or unnormalized scores that needed careful tracing to catch. If I were to take this further, the main thing I'd want to solve is the per query index rebuild to make this scale past small document sets. Overall, every change here traded a small cost, whether it's speed or complexity, for a real gain in accuracy or correctness. Thank you for listening.